Welcome, everybody. My name is Jacob Smith. I'm excited to kick off our conversation here today. I see a lot of familiar faces here, but for those that don't know me, I am the community director for Altimetrik Collider Detroit. So representing a company, Altimetrik, which we actually have a number of Altimetrik representatives in the house here tonight, which is fantastic. We are a digital transformation company that specializes essentially in helping companies stay ahead of the curve with the ever-changing landscape of technology and source innovation from within their teams and all sorts of other exciting stuff. As I mentioned, I'm specifically representing a project within the Altimetrik team called Collider, which is a community-facing initiative that is looking to build community and help software engineers connect and grow in the Detroit area and beyond in this exciting COVID world where everything is virtual. Our reach grows all the time. So that's exciting stuff. So to that tune, I encourage everybody tuning in. If you haven't already, we'll drop some links in the chat to connect with us and learn about more exciting opportunities for programs and other tech news and job opportunities, all sorts of good stuff that we are consistently posting on our social media, in our e-newsletter, on our YouTube channel, and more. So we encourage everybody to connect and yeah, don't be a stranger. So without further ado, I want to go ahead and jump into the session because we've got a big one today. We are talking about leveling up your load testing with JMeter. JMeter is an Apache tool. I imagine if you're not familiar, you may have looked into it. If not, at the highest level, it's an open source load testing tool for analyzing and measuring the performance of different types of services with a focus, as I understand it, on web applications. I'm going to hand it off to the folks that are a lot smarter than me and more knowledgeable to tell you more about it. Today, we are joined with several awesome members of the Altimetrik team. They are each senior full stack engineers that really know their stuff. Ankur Sharma, Ryan Moussa, and Yvan Gakuba. They each, as I mentioned, work for Altimetrik and are actually all working full-time at Ford Motor Company in Metro Detroit. And so, yeah, without further ado, I want to go ahead and hand it off to our superstar roundtable.
Good evening, everyone. My name is Ankur Sharma. As Jacob just mentioned, I'm one of the principal engineer for Altimetrik. I'm representing one of the clients here in Dearborn, Michigan, and today we're going to talk about load and performance testing with JMeter. It's not a new concept. This has been in load testing has been a critical part of our quality-driven production development since for last 10 years or more. And it's the same concept that we should make sure that we are covering all different kinds of performance tests, all different kinds of load tests, all different kinds of stress tests on our product to make sure it's ready for production, both in terms of your application, that it has the capacity that it needs, and also in terms of infrastructure, right? So the concept is pretty old, but since we have always evolved in terms of infrastructure, earlier we used to have servers, now we have all this rapidly generated, pay on demand cloud infrastructure. We have so many services that used to be, stable and server-based, such as SQL databases, big databases, which are again now moving to cloud infrastructure. So all these capacities and infrastructures are now very easily scalable. So that gives us an opportunity that even when we are doing load testing, which is again, it's a pretty common concept, how we can, adjust it, how we can evolve to make sure we are making the best use of our infrastructure, we are making best use of our scaling capabilities, and we are not, wasting resources and we are not overpaying for resources. So this is, we're going to talk about all these concepts that are not only just within the load testing or performance testing domain, but how it fits into the overall ecosystem when you talk about an enterprise level application or a production ready product that you're going to launch in the market. Feel free to stop me anytime, and because we have this is again, it's a very generic and big concept. So we're going to just go through this agenda that we have planned for, but feel free to stop us anytime and we can deep dive into any topic as necessary. Sounds good?
Sounds good.
Good, yeah.
All right, awesome. So, quickly going through the agenda, we're going to talk about the JMeter tool. If you have some experience, then that helps, right? But if you're not, feel free to, discuss about. We're going to talk about the most common and important topics. It's a big tool. It has been evolving over a decade. So there are a lot of different flows and capacities and ways you can perform or implement a performance and load test, but we will cover the basic jargons around JMeter tool and load testing. Then we're going to talk about automation. Again, in this era, we don't want to do something and just make it static. We do want an automated flow because product is going to continuously evolve. You will move from version 1 of the product to version 2 to version 3. And if we talk about cloud applications or microservices, you have one endpoint, then second endpoint, then third endpoint. It's continuously evolving. So do you want to do that effort of continuously creating your JMeter test, adding all those validations again and again, and making it again, your test plan, which is pretty simple on year 1, becomes pretty complicated by year 10. So how can we automate the whole process so that as your code is growing, JMeter test plans are automatically evolving. So we'll talk about automation that we have already implemented and how we can implement the same for different use cases. Cloud native application, again, this is the current era where we are. We talk about all these cloud applications and microservices, as I mentioned earlier. We should be able to scale them either manually or automatically. We should be able to understand what is the peak load, mid-peak load, off-peak load that an application can go through and be ready for that. So that and be proactive for that load so that we don't fail when more users are actually using the application. That is a good time for us that we are getting known to the world and more users are using the application, but we don't want to fail at that scenario. We want to be actually prepared for that. And then with the load, numerous application errors like memory issues, CPU limits getting hit. Sometimes we have cloud databases now, which are obviously pay per demand, right? So the demand is increasing now with more load and users. So we are going to hit all these limits in terms of DTU, CPU, and causing failed connections and deadlocks. How do we proactively handle all that? We're going to talk about that. And then the last topic is pretty interesting. It's about chaos engineering. Load and performance, if it's managing your overall application, if it covers your application 100%, then it can become a very critical part of chaos engineering. And then it does bring a new factor into your product, which is your product is resilient. By resiliency, if you add that factor to your product, that means that there is no error left, which will not be captured by your product metrics, and developers would not be notified proactively, right? So everything that, every error that system generates would be captured by the system, and whatever metrics you have set up to capture your errors, whatever notification system you have, we have email notifications to tell us about all these errors, be it infrastructure, be it application. All those can be verified with a resilient product or through the chaos engineering practices. All right, talking about different types of tests, again, performance tests, just giving basic definitions here. We have these three different types of tests that we can cover through JMeter. Performance test, we definitely, if we have developed an application, we definitely, not only for our customers or our managers, even from development side, we do want to manage all those NFRs and those performance numbers. That yes, if you hit our microservices or our applications, you're gonna get response within 2 seconds or within milliseconds. All that should be known. So we can actually capture all these metrics through our JMeter test and their results, right? We can track on what kind of load, what kind of performance we are getting, right? Load test is pretty simple. If you increase number of users or number of threads that are actually hitting your microservice endpoint. That is the load. And once you apply all that load, what changes for your application? Does the performance degrade? Does the application starts failing? Do we hit our infrastructure limits? All those can be verified through JMeter test plan. And then accordingly, all these tests are actually performed in a separate performance environment, which is again part of your pre-production environment, right? So performance environment gives you ability to perform these different tests and prepare yourself in the right way and set up the right production environment. That's the overall goal. The goal is not to make sure that you can test this on the product. The goal is that you can handle real world load, real world peak load in production without any failure. All right. So, and stress test is similar. We are continuously, let's say a span of 30 minutes, or maybe 60 minutes or 2 hours, we are continuously hitting the max load on your application. And if there is a memory leak or any kind of data leak happening, eventually with time, that load will break the system and the application. So all these are not separate tests. All these factors of different types of tests can be a part of single JMeter test plan if we put the right assertions in place. Any questions? Any points here? All right. We have a few slides on talking about JMeter, but I think it would be better if we just show it on the tool itself. So we have a rough test plan that we will go through. Main factors that we see whenever we are building a JMeter load and performance test plan is first to understand, what kind of load do you want to put on, right? And in terms of JMeter tool, we call them threads, right? Threads could be number of users. For example, when we make this, I'm assuming everyone is aware of Postman. Let me know if you're not. So on Postman, whenever you call an endpoint, one call is going to one endpoint, one thread is created, and that's like a singular event travels across your microservices. With JMeter, it's the same thing. Only thing that you can change is instead of one, you can increase these number of threads to whatever number. Let's say this is a thread group. I can make it 15. And now that single endpoint is getting 15 calls at the same time. I can make it 150, 1500. Depends what is the kind of load you want to verify on your application. So these are the number of threads or number of concurrent threads that will hit your endpoint, which are present in this thread group. And that's how we add concurrent calls or parallel threads to your singular Postman testing. Through JMeter, we just added concurrent processing and concurrent testing to it. That's why this whole concept of thread groups is pretty important. Should be clear to everyone who's trying to implement a JMeter load and test plan, right? Few more factors. These are simple properties. Ramp up period is after how many seconds do you want this to scale up, right? It takes 60 seconds to start this thread group. And then you have other factors. Either you can have a fixed loop. Let's say I want to loop this thread group or all these endpoints here, they represent a Postman HTTP call. A thread group is just bundling of those calls. And on thread group, I have set up that I will call these endpoints 10 times. I will go from 1, 2, 3, 4, then I will come back and I will keep looping for 10 times. So this is like how many times you want to keep your system under stress with this 1500 concurrent calls load. Or if I don't want to do it by number, I can say forever here, and I can set up a scheduler where I define the time for which I want to maintain the stress or maintain the load. And I can say 1800, which is 30 minutes, or I can say 3600. So now, after this configuration, what I've done is I will be making 1500 users would be hitting all these endpoints at the same time. And we will keep running that load for 1 hour after an initial delay of 10 seconds. And then there's also action that we can set up here on the top, action to be taken after an error. And let's say any of those calls fail, any assertion, what do you want to do? Do you want to continue with the next one? Do you want to start the next thread of the loop? Do you want to stop the thread? Do you want to stop the whole test? And do you want to stop the whole test immediately, right? Stop test means it will stop after the call is giving you error, or you just stop everything immediately. So it depends on your use case. So based on these different scenarios, you can actually divide your endpoints into different thread groups. Let's say for this thread group, I just want 10 calls and make it run for 30 minutes. And I want to move to the next thread. For this thread group, I want to have a different configuration. For example, this is another thread group where we just build a token, right? So here I don't want to loop it so many times. My token is valid for 1 hour and my whole test is valid for 1 hour. So I will just run this once. And then I have a token here. I make this call to Microsoft Azure, get a token, and that's it. This thread group is only running 1 time. But with that token, I'm making these calls 1500 times or 1500 users. With the same token, I'm going to another thread group, testing few other endpoints for 10 users in parallel. So these thread groups allow you to group your overall load testing plan based on what exactly you want to test and how you want to put load on a set of endpoints. Could be one single microservice endpoint, such as getting a token. Could be set of multiple microservices and their endpoint. Depends, right? So that's the number one thing that separates out, your regular Postman call, which is just request response for a single thread, into a JMeter request response with multiple threads. Understanding of thread groups.
Hey, Ankur.
Yes.
Before we move on, there's a question in the chat here. If I don't think you answered that one yet. What if you want different sets of users on each endpoint?
Right. So that's the next step that I was gonna show it to you. That's a very valid point. And yes, we do want different set of inputs. So that's where our external input configuration comes in, and we do that through CSV format. And I will show that. It was actually the very next point. Definitely, when we are saying 1500 users, we can't just have same user ID. That would be, that may not be effective or a valid scenario to test. When you want to test 1500 users, you want to create an environment where these are 1500 separate users. Maybe you want to have a different user ID. You want to have you understand user by their location, lat long, so you want to have set of those different values. So that is how you provide input to this thread group, which would be responsible for creating these threads or creating these 1500 users. On the JMeter tool, you can always add that as a config element. You can right click on thread group, go to, these are all different components, and we will cover the important ones one by one. First one is config element, which is CSV Data Set Config. And there are other like header managers, cookie managers. These are all different ways to provide different set of inputs. But for that very question where you talk about different users, we can use CSV Data Set Config. And we have been doing that in this example too. So this responds to a particular CSV file. And let me actually show a sample one. Make it clear. So let's say this is one CSV, which is having set of 15 different VINs, right? Some vehicle identification number. And this is the CSV that I use here, right? And then I'm picking up a column VIN. Right. So I'm saying, let's say, so this is how you can add 1500 user IDs in this page in your CSV. And then you put that CSV here as user IDs.csv, and you can create a name to your first column. You can have, it's up to you if you want header in the CSV. There is a factor here which says header is part of the CSV. Yeah, ignore the first line, false or true, right? That means it's an header. And then next thing, let's say you want another thing. You want latitude here to identify user location, 12.0 something, 37, 234, things like that. And then if I want that factor, it just becomes comma lat. These are my variable names. I can name them anything. So I can, all those CSV different variables for which will represent 1500 different users can be part of a CSV. And now that CSV is part of your CSV data set config. This also, it's up to us. Do we want it for all the threads or for the current thread group, right? Generally, and accordingly, you can, all these components are free flowing in nature. You can put them on the top and say this applies to all the threads. If it is specific to a thread group, you can move it inside a thread group and say this just applies to current thread group, right? So they always, by default, all of these components have that parent-child relationship. So, and you can change that by just replacing it. If you place it here, now it applies to, by default, it should be applying to all the threads because of the placement. So you have to change that property accordingly. If you're placing it inside one, then we should make sure that it says current thread group, right? So this thread group is using this configuration and it's picking up these two columns from that CSV. And what you have done is you have changed these two columns into two variables for this JMeter test. Now it's very easy. You just use them. For example, in this endpoint, I want, when I'm hitting this endpoint, I'm using this win variable, right? So when my load test or JMeter hit this endpoint, this thread group says 1500 users. Or I'll stick to my example. So here I'm calling it, these 1500 users are 1500 different wins. My CSV has provided a list of 1500 different wins, and the variable name is win, right? And then in my endpoint, I just provide that variable name. Now, when I run this JMeter, this endpoint would be at the same time, 1500 calls will go to this endpoint, and all of those calls will have a different win in the URL. This is the path of the endpoint, right? So I can use this variable same way I can use it in our request like this, $curly brackets win, or I can use it in the path, I can use it in the header, but this variable is created based on this CSV and this variable name. And we can have comma separated multiple variables too. Does that answer your question?
Looks like he said yes.
Cool. I'm actually not looking at the chat. I should be looking at it. Let me open it in window. All right. So, yep. So
sorry, we do have another question. Oh, I lied. Sorry, that was the one that was answered. Thank you. Sorry.
Okay, no problem. So yeah, so this is how we provide, inputs from CSV, and it's pretty easy. Input can go to one or many threads, right? But yeah, we got to try to see it working. Then next important component is once you have your threads defined, which are saying that I want to put a load of these many concurrent users for, let's say, 30 minutes. You also have your input defined that these are the 1500 wins, which would be going through all those endpoints in that thread group. Now, your next event is what is actually you are testing through your JMeter. So JMeter has two types of controllers. We call them samplers and controllers. Both are, controller in a way. Samplers is what type of call actually you are testing. Could be an HTTP request. I'll actually show you it on the tools to make it easier. So when we have this thread group defined with this, and first thing we did is we added a CSV. Then we can right click, add sampler. And more or less, we are backend team. We are handling numerous microservices as part of our application. So we just always go and create a test request. Oh, sorry, an HTTP request, right? Because we want to hit a microservice endpoint. There are numerous ways to directly go to a database to JDBC request. There are also bean shell sampler, which I will also show, which actually helps you to create your own properties during this testing. There's also access log sampler, JUnit request that you can trigger on your existing microservices. And there are also other samplers. You can also trigger an email through SMTP sampler. You can hit a FTP call through TCP calls, and there's also FTP requests that you can do. There are numerous ways. At our end, we have more or less only used HTTP request and bean shell sampler because we just want to test our microservices. But there are a lot of other samplers to trigger different kind of network request. Right. So HTTP request is pretty simple. It shows up like this, and you can set up what kind of protocol you want and which server you're hitting. So this is either my gateway URL, which gateway is calling my API microservice domain URL, or whatever microservice you have, you can just put that URL in here. So if you have a backend service and let's say some app is calling a backend endpoint, that will come here as an HTTP request detail. Good thing for us is all these exposed APIs, they all come through singular gateway. So all the calls in our ecosystem goes to the gateway. Gateway then route it based on the path. It will route it to either microservice 1 or microservice 2. They all have different paths, right? So we have path-based routing. But if you don't have a gateway and you directly want to test your multiple microservices, then simply move that to each and every endpoint. And that for that endpoint, you can say, microservice1.com, whatever that URL is, and you can call that one. But if you have a common gateway, then you can define it for the whole thread group and say whatever gateway you have at enterprise level and use that. So this is just simply defining endpoint. If you have multiple parameters going into it, there's also request body here, whatever is required. Since this is defined for the thread group, so mostly we just define common points here, which is gateway. You can also define proxy if you have any proxy. So we have proxy server and port numbers that is defined here. Like for this thread group, we don't need proxy. Maybe we do. Okay. But this thread group had a different server name. It's going to Microsoft to get the token. This thread group is going to our gateway. And again, this thread group is also going to our gateway. So they have common set of URLs that we can use. Right. So, and then all these endpoints inside the thread groups are using the same thing. So this is one of the samplers that you can add. Another sampler is, or another config element after your dataset config is your header manager. Header manager is nothing. All our calls that goes to our APIs have numerous headers. And this header manager, you can maintain what is the content type, application JSON, your app IDs, and your whatever headers you need. If they are common in nature, add them on the top here. And that means it applies to all these endpoints. If you need something specific for that particular endpoint, add it here, right? So for this endpoint, I will be using this specific header, and I will also be passing these common headers, right? So it depends. Simple structure that we can do Obviously, we can also add all headers here and repeat them. But whatever was common for all these services, we moved it here. And then the unique ones are under that particular request. Right. So those are more or less controllers. There's also logic level controllers, or which actually are can become pretty complex, but they help you program your test cases. We have not been using it because we don't directly create our test plan from JMeter. We actually automate it from Postman. So since Postman have a simple flow, so our JMeter also have simple flows. But JMeter does have this controller where you can put your looping in your loop controller. You can tell one particular endpoint will run 3 times for those 1500 calls, right? We can have caching controllers. We can also have for each and if else and switch controllers. All that is possible. That let's say endpoint 1 gives you, an enum response, which could be pending, completed, or failed. Now you can actually read that response value and then call a switch controller. And based on that response value, switch controller can go to either endpoint 2 or 3 or 4. Right, so all those controller things are possible, and we have not done that because again, our JMeter is not programmed manually. We have automated it, which we will talk about in the next slides. But these are also important areas that we need to implement and understand to create a JMeter test plan. So again, another important thing is preprocessor and postprocessors. There are numerous options, as you can see, that are available. But the goal of preprocessor is to make sure that if your current endpoint requires a value from the previous endpoint, then you can set them up in the preprocessor. It could be fetching a value using a regex, fetching a value from the database, fetching a value from CSV variable and reforming it. So all those, and there's bean shell preprocessor in the end, which I would show here. I think we just have postprocessor mostly. No preprocessor here in this example, but what I can do in this bean shell preprocessor is write a script, something like that, to either get a property or set a property. Right. We will talk about this. Is again something that we learned on the fly. That there are numerous ways how you can pass your values and variables. One thing we learned is from CSV, you can bring in outside external input to your JMeter. But also a lot of times you want to carry value from one JMeter endpoint to your other JMeter endpoint. You also want to carry your token from one thread group to the API calls in the other thread group. So all these value transitioning or data travel requires different kind of preprocessor or postprocessor, right? And we will see a few examples. But overall goal is to make sure that we can pass all that data between these endpoints. And so for example, if we look at this token, we make this call, JMeter will make this call once, and we have a Json Extractor, which is postprocessor Json Extractor. What that Json Extractor is doing, it's saying if you see this variable, $ is the root JSON path, and dot token is the first property on the root. We can go further deep. For example, if it's a complex property, we can go to dot access token, dot value, dot text, whatever is depending on what kind of JSON you have. But since tokens are more or less pretty simple, it's like this. So we are trying to fetch this property from the root. So this would be $.access token. Again, jmeter.com has all these syntax and templates define how to fetch these properties, be it JSON expression or XML expression. Accordingly, whatever you are comfortable with, you can either use a JSON extractor, a jQuery extractor, a regular expression extractor, an XPath extractor. But overall, the goal is pretty much same. Fetch a value from the response because future next calls, upcoming calls need them. So you fetch this property and you set it up into this variable. Then if you want to use this variable in this very thread group, all you need to do is $ curly brackets Azure AD token and that property, that variable is available. But since we are using this property in another thread group, so you have to use a bean cell assertion where you map this into a new property. So you're actually now creating a new property calling Azure AD token because variables don't travel through thread groups, property do, right? So once you have created a property such as this, now you can use it like this, using this. So again, syntax is again, pretty much available on jmeter.com, but the core point here is that variables can travel between a thread group endpoints, but to make it travel across thread groups, we have to create properties, which we can do through bean shell scripting and assertions. All these assertions are kind of your test cases. Like if I go to Postman and I create a test case, right? Here I'm just setting a variable. But if I have a test case that response should be 200. So if I come back to JMeter, I have to actually right click here and create a create an assertion which says, response assertion, which means I want to verify something on the response or assert something on the response. And here I'm doing a very simple check. I'm saying my response code here should be 200 here at the bottom. And I can also do comma 201, 202, whatever I want. If the response is not 200, my JMeter error is created. And then accordingly, based on my thread group setting, I can still continue, or I can break the thread or stop the test, right? So this is that I'm testing that what is the response code coming from my get token call. Another pretty common assertion is the duration assertion, because obviously through JMeter, we also want to verify when I increase the load, does my performance degrade or not? So here I'm saying this call should always be completed in 2 seconds. If this doesn't happen, then again, my JMeter error is created. And based on the thread group setting, you will actually either stop the test or stop the thread, or you can choose to continue. It's totally up to you. So these are, again, these are assertions that we have for all the endpoints. For a particular thread group, generally these are common, like 5 seconds is our NFR with our max load for these endpoints. And we always want a 200. If this doesn't happen, thread will create an error. And then next step will be decided based on this. So when I make 1500 calls, 1500 threads, and let's say this one doesn't give me a 200, then 1499 will continue, but one of them will stop, right? But since I'm still looping, so that one thread that stopped at, let's say, this is 1, 2, 3, 1500 passed and, passed this stage successfully, 1500 passed this stage successfully. 2 of them failed this stage. So those two threads will end or will die, and they will again reach here. Because we are not stopping the test. We just want to stop the thread. But since we are looping forever, new threads would be created for those 2 wins because they will continue to loop. So new threads, those 2 will start from here again. So then the load of 1500 remains on your system. The stress remains throughout the journey of this, 1 hour.
Yeah, Ankur, quick question here. So the question is, could you please talk about chaining, or how to use the response of one API as an input parameter in the URL for another API?
Sure. So as I said, if you're talking about endpoints within one thread group, then we can use variables. If you're talking about inputs between two thread groups, then we have to use properties. So let's say we talk about two thread groups and create a property. So let's say I made a call to get token. I extracted that token using a JSON path into this variable. Since variable cannot pass thread group, so I have to create a property. So I do a bean shell assertion, and I created a property from this variable, $AD token. I created a property. Actually, it's the same name, but let me actually make it easier. We will call it. Now it's a property AD token. So from variable AD token, which came here, let's say I call it variable AD token. If this endpoint was here, let's say in the same thread group, I could have used the variable directly. I don't need this bean cell assertion to create a property. But since it is not in that thread group, it's in a new one, so I have to create a property. So I come here, I create this property. Now, since I have a property, it can be used across thread groups. So I will come here and I will use my property. Oops, here. So this is the syntax, this is the token. And I can use underscore property, dollar curly brackets, underscore property, name of the property to fetch it. So that's how it travels across the thread group. That's how I chained the token response from one endpoint into the header of another. So this is the property flow. If we talk about within the same thread group, how it travels as a variable. So one way we showed variable is your variable from your CSV, right? Which you can use again as $Vim. Another way to show variable is through here. Let's say this is one request that we make that we hit an endpoint and we get an response where we expect this property. This property creates this variable OC1, and this is like any other variable. Variable from your CSV and variable from your JSON extractor works the same way. They are called variables. And now we can use them simply with dollar curly brackets, name of the variable. So within a thread group, it's pretty easy. You don't have to do any programming. Just extract them into a variable and use the variable. But you need to program it as a property if you're going traveling within multiple thread groups. So that's the major. Then we have a lot of listeners. Listeners are nothing. These are different ways of reporting your JMeter results. Obviously, the goal of JMeter is not just to, if everything is giving you, 200 response and everything is within your limits of, let's say 2 seconds limit was set up and everything works successfully. It's actually a bad test. You learn nothing. The goal of JMeter is to actually learn the limit of the system. You have to understand when you can break the system. That is the goal. Because if 100 users is giving me 0 errors and everything is responding within 2 seconds, I learn nothing. If with 200 users, I start seeing 10 errors, that means something went wrong. Was it my capacity of the application, memory, CPU? Was it the capacity of my infrastructure? So we need to analyze all those areas. So when you get these errors, so these reports are actually very important. This is a local JMeter test report that you can see on the console. Since I talked about automation, we are using CI/CD pipelines built through Jenkins to actually save the reports in our Jenkins dashboards so that we can analyze, and we are recording history, and we will show that too. But overall, you can record this, like which endpoint was executed, why it failed. We were expecting this value in the response, but the value was different. So one of our response assertions, something like this JSON assertion says, this value should be false always for this endpoint. We can test anything. We can put a JSON assertion and say, in the JSON response, I expect this value to be false, but it failed. My report says it was true and not false, right? So So whatever, all of these errors will give you different, this one failed in duration. It was supposed to take 5 seconds, it took 6 seconds, right? So these are the different listeners. It's pretty easy to set them. Again, you can set them either at the whole test plan level, or you can just drag them like it is already here at the thread group level. And you can right click, add, these are listeners at the end, and pick what kind of report you want, right? And then mostly there are summary reports, which are here. I don't have one, but we'll show you in the Jenkins page. But overall, these are different ways to record your data that came out of your JMeter test plan execution, right? How many calls failed, why they failed, and then you can analyze the root cause through different channels. It could be your application error, it could be your infrastructure, it could be your memory leak, numerous errors, right? And then another thing you can definitely do, if you have some kind of metrics like log files, like every error that happens in production, you're supposed to record them or generate an email and notify development team that, just to be proactive. Few teams have VictorOps incident reporting. So now with JMeter, you know that when you ran this JMeter, some out of 1,500 users tested your whole application at one single go, and out of those 40 users failed, got errors. So now you should be able to track in your incident reporting or whatever metrics you have in your application, that exact match should be there, that 40 errors should be present for those 40 users, right? 40, 100, whatever count you see here should also be reflected in your metric system. And we will try to cover that in our chaos engineering session. All right, it's already 6:20. Just try to wrap this up quickly. This is now we are moving towards automation. It's pretty easy. I can give a very quick demo. So you can go to your Postman, and that's all what we have done. We always had Postman for all different scenarios, end-to-end flows, database services, third-party services, because it is part of our integration testing. We always run a Newman command in our pipeline, which tests all these Postman endpoints, and then we build it. Now I can just connect this Postman to a JMeter recorder by something like localhost 8888. Once I do this, and I can go to my JMeter. This is nothing. I can on file go to templates and pick a recording template, and you will see something like this. All right, I will remove the previous calls. So right now my recording controller is empty, and I was already running this. So I will stop this, and I've set up a test script recorder at port 888. It's running in localhost, so it is localhost. I start recording. Once I start recording, now your JMeter is listening to all the events that are going to happen at this port. And I've updated my Postman to use this port as proxy server. As soon as I do that, every endpoint I hit. So you don't care if your request is success or failure here. The goal is recording, right? Since I'm on my client proxy, so obviously it won't run successfully. But my goal was recording. So if I go back to my recorder and I see I actually recorded that Postman activity. And that's it. I just have everything here. You can change the name to make it easier, make it user-friendly. But that whole activity that we just ran, it got recorded. So now if you already have a Postman collection, just go to, just run your collection. And that's it. You will have your JMeter test plan created automatically. I just need to run this collection. And for this Postman collection, I will have a valid JMeter test plan. And that's what we are doing. So we just focus on Postman collections, which is part of our development cycle for our integration test cases. And at all times, we have a ready-to-use JMeter test plan. Right? We don't have to work on it again and again as a duplicate effort or something. So it's easier to manage. So that's one level of automation that we did in creating these test plans. So you can always use test script recorder from JMeter. And you can also do this on the browser. If you have a UI application and from browser, it will also capture that one. You need to change your proxy setting of your Chrome browser or Firefox to point to localhost 8888. And then whatever network activity you do on the browser, it will be captured on your JMeter test plan. Next level of automation that we wanted to do is that since we are having our pipeline where we do our unit testing, our integration testing, and we are doing these on QA and staging environments, and we also deploy to performance, why don't, along with in this pipeline, we also do our load testing in our performance environment? So we, since JMeter it's a command-based tool, you can either use this tool to run any test. Let's say run, and it will run the test, or you can run a command. Oops. Or you can run a command as a shell script in your pipeline. I can show a quick example. Oops. So here, this is just one, as soon as we change our Postman and we push it to GitHub, a JMeter test plan is created automatically, and this pipeline picks it up automatically, and it runs JMeter by running these commands. It is connected to a GitHub folder, which is here. So we just push a Postman. Postman automates into a JMeter test plan. JMeter test plan, this GitHub repository is connected to this Jenkins job. Jenkins job execute a JMeter command on that particular test plan, and there is a plugin in Jenkins which is a performance test result that is also set up to create a report, and automatically a report is created, which looks like this. On Jenkins, if I look at this particular test plan, we have been running so many builds automatically, right? And whenever we want to look at the report, we can go to last report. This is with chaos, something failed. This is again another one. And this is one where we were success, right? Out of 10,000 calls, we received like 0.57% of error. And then we were able to identify all the errors were because of some delays, which were caused by a backend system or a team. But yeah, we were able to track each and every flow of the application. You can also click on any endpoint, look at each and every user. Now this is one thread, multiple threads, close to probably 100, 200 threads on the single endpoint, which is this guy. And that way you get all the graphs and metrics in Jenkins itself. You don't have to run JMeter manually and locally from one developer, and for that person to manage all these test results. You can automate it via any other CI/CD, Concourse, Microsoft Azure DevOps, whatever is part of your ecosystem. But plugins are available, and because it's a command, JMeter can be executed using a command line, and every tool supports that. Every CI/CD tool supports that, so we can build a report and maintain them on Jenkins itself. So that's a piece of automation that we are doing continuously. So every time our code moves to master, a parallel deployment, other than deploying it to staging, a parallel deployment takes place in performance environment. And we also, pipeline also execute load and performance test plan on that performance environment. And any Jenkins is also configured to give a Slack notification. Whenever we get errors more than 1%, we get a Slack notification that load testing is not, efficient enough, and we can take actions accordingly. Numerous concerns why we do JMeter. It's, overall goal is to make sure that in production, you either set up manual scaling proactively, or you have automated scaling, and you have the right infrastructure at all times. That's the overall goal. Cloud application directly that you can test is database services. Pretty easy. If you control the database and you have a DB service, it can directly have its own individual load test plan. Third-party services, for example, if your one microservice is calling a third party, let's say PlugShare, we are in charging ecosystem. So we do call third-party services like PlugShare, like Genability. So definitely, and they have an agreement, right? So PlugShare will say that they can support 500 concurrent users and they can support 10,000 calls in a day. What's the best way to verify that agreement? Just put that kind of load in JMeter and test it out. You can verify their agreement, whether they are true to their agreement or not, right? Similar thing, end-to-end flows, which are across multiple microservices. The example that I was sharing, that was actually traveling through multiple microservices across multiple thread groups. You can also choose, this was one of the common settings, do you want thread groups to run in parallel or one at a time? So we are actually running these two also in parallel to just further the load. This will be 1,500 users. This would be, again, 1,000 users. So actually, the system is handling 2,500 users, and those users are going through different parts of your application based on different thread groups. So these test plans and these applications, overall, this is where they will break your system. Either your system has not scaled enough. That means you don't have enough memory or CPU limits. On the right, there's a diagram on the right, manage auto scaling. This is from our PCF, where we have deployed all our microservices within the application. So it scales up. We have minimum 3 instances, maximum 8. And based on HTTP latency or CPU utilization or memory utilization, we will scale up, right? So that is how we are doing automated scaling and staying ahead of the curve and managing peak load, right? So that is the main concern. How do you scale up automatically or manually? You should be proactive enough. If you know Thanksgiving is coming and you're an e-commerce website, so on top of automated scaling, you do want to manually prepare yourself for that kind of a load, right? So those things does help either in automatic fashion or manual fashion. Then you have cloud databases. We are using Azure databases as our, in our ecosystem. So they also can hit their limits. There is a DTU limit, there is a CPU limit. You can actually come across deadlocks. If there are memory leaks, you can come across failed connections if you don't have the right infrastructure. So this diagram shows it, how you can track it. On top of it, you can set up your Azure alerts. So this is one of the metrics in our performance environment. So we did actually hit our limit, and we have to scale up our performance environment. When we moved from 100 plus users, it did hit our limit. And what we did is, earlier we had very basic setup. All right, so we were having basic setup for that particular database. It was 5 DTU, and realized it's not going to handle 100 users worth of load. So we moved to standard, right? So these infrastructure also, you can set up alerts where whenever you're hitting 90% DTU limit, you can get an email notification. And then accordingly, during that intensive load, you can move from standard to premium, or you can, within the standard, you can increase your DTU limits. But these infrastructure you have to address manually, and that is only possible if you're continuously, tracking the load on your servers. But through load testing, you can understand that beforehand in your performance environment. to plan for your production. Actually, we are close on time, and chaos engineering is a big topic in itself. But if you have experience with chaos engineering, and I will actually like to move to Q&A before we actually go into this one. But what we have done, wanted to show this, but I think we are out of time. What we have done is with chaos engineering, we mix and match load and performance testing. So we did actually create a hell lot of chaos in our system just to see how resilient our system is, right? So it was pretty interesting. Maybe we'll cover this in another session, but it was an interesting thing to see that, because in real world, if system breaks, you will be getting thousands of errors, right? Although they may all have one root cause, but you do want to record if 1,000 errors happened and you have all these metrics, say system error logs, Splunk dashboards, Dynatrace, you do want them to report 1,000 errors. If they're reporting 50 or 500, that means even these metrics or these log analytics do not have enough scaling capability to record everything, all the errors of the system. So that's what we did. We merged chaos. We turned chaos on in our performance environment, ran our load and performance tests, created a real world chaos scenario, and then we compared. If JMeter says 1,000 errors, does Splunk also says 1,000 errors? Does Dynatrace also says 1,000 errors? Do we have 1,000 emails with those errors, or Slack notifications? So, but yeah, we will probably demo that in another discussion. So, but yeah, that's all we had for the plan.
Excellent. Well, there are a couple of questions here in the chat, Ankur. I'm not sure if you can see that, but Al is asking, what JVM do y'all use?
So we are all on Java 8, and we are using Spring Boot microservices at the back end. Is it with respect to the JMeter version?
Al, do you want to clarify if you were talking about JMeter specifically?
No, I'm talking about the Java virtual machine. Are you using Hotspot, Azul, or something else?
So instead of Zool, we have Spring Cloud Gateway, and that's actually our gateway here that we use. I don't have the real URL, but yeah, we use Spring Cloud. We have APIM gateways first and that is at the enterprise level coming from the company. We have APIM gateways. They take care of DDoS attacks, like multiple application ID cannot put enough DDoS attack on the system. Then we have our internal Spring Cloud gateways, which used to be Zool in the past. Now it has improved and grown as a Spring Cloud gateway, and that take care of any kind of DOS attack or unsecure or cross scripting calls or SQL injections. And then that gateway eventually reaches our microservices based on the route.
Great, and then another question from Ashwi here. So can you see the question, Ankur? It might be easier for you to read this one, or I can read it.
Right, so I have a preprocessor user parameter. I would like to use this controller on top of my test plan so that all line points can use this parameter for the company and use it within a request. So generally, if you have a preprocessor user parameter, it is only available here. If you don't see it here, then you won't be able to use it. Oh yeah, you have it. There you go. So it depends on how you have placed that user parameter. So make sure that that user parameter is, now this user parameter will apply to all thread groups and to all the requests.
Great. Okay, so everybody, just in the interest of time here, if anybody, I think we could probably sneak in another question, but while we're doing that, thank you so much, Ankur, for the awesome presentation. And I know Ryan and Yvonne, I know you guys helped put that presentation together as well, if I'm not mistaken. So thank you to everybody who helped bring this program to life. Really excellent stuff. Yeah, and so it looks like there's quite a bit of interest in continuing to talk about this particular topic, to dive deeper into JMeter with the chaos engineering and maybe some other things. So I'm excited to explore that and think of some other great topics in the future. I dropped some links in the chat here for folks who aren't yet connected. We strongly encourage everybody to connect with us. We've got a great e-newsletter. We're on Meetup, YouTube, all the different social media channels. Definitely don't be a stranger. We would love to hear from you. If you have ideas for topics you'd like to hear about, if you have any feedback for this particular program, and yeah, for anyone tuning in, please don't forget to connect with us and tune in for more events in the future.